All right, here we go. 7-Eleven, open 7 days a week, 11 hours a day. 7-Eleven, 7 hours a day, 11 days a month. Anyway, quiz 7-Eleven. Arc sine of 1/2. Okay, so I have our book open. I have some graphing calculators open. I have the other video processing so I can upload that to YouTube. That's the mini lesson, 710 mini lesson. Talks about more of these ideas. But arc sine of 1/2. Arc sine of 1/2. So for those of you who choose to just watch this one, that's asking for the inverse of the sine function who is equal to 1/2. So if the sine function gives us that ratio of the opposite over the hypotenuse for a given angle, the arc sine gives us the angle for that ratio. So what we're going to do is we're going to come in here and we're going to take a look at the arc sine function. So if we want the arc sine of 1/2, remember it's x is cosine and y value is cosine. We look for it. Aha, there we go. So according to this, there's the sine value. The arc sine gives us the angle, so 30 degrees or pi over 6. Pretty cool, right? Again, in that other video, we stumbled through domain and range. We really talked about what is an inverse, what does it equal, and why, like the horizontal and the vertical line test. So again, lots of thinking and examples of what it's like to just kind of really work through these ideas. It's okay. And then here's the formal definition. Remember, your book is a great resource. See, there it is. There's the domain. There's the range. Okay, if you watched that video, there was a little sentence I didn't quite agree with. And I'm happy here. So this domain is restricted and the range is restricted, but notice how the range is actually this gray part on our unit circle. Okay, and that's kind of an important thing to recognize when dealing with that inverse so we know which angles we will be looking for. Okay, so our question, sine 1/2, pi over 6. Pi over 6, okay. Arc sine of root 3 over 2, watch, so it's pi over 3 is the answer. But when we go look at the angle pi over 3, the y coordinate on the unit circle will be root 3 over 2. So here we go. Pi over 3, there's our angle. The y coordinate, the sine of pi over 3 is root 3 over 2. Okay, we'll do the last one. Root 2 over 2, we come back. Root 2 over 2, so it's pi over 4. If I went too fast, go ahead and try it yourself. Okay, question, what is the value of negative 1/2 in degrees? Same thing, it's arc sine, so we're looking for the angle whose sine is negative 1/2. We go back to our unit circle for now. Here is the sine of negative 1/2, but we aren't going to write 11 pi over 6. And the reason we're not going to write that is because of the output restriction. So now the output of our inverse function is going to be between negative 90 degrees and positive 90 degrees. So what's happening over here is you're having this rotation, the positive rotation up to 90 degrees, right? Because we're going counterclockwise, so it's a positive angle. But now instead of rotating around, we're going to rotate backwards. We're going to swing down. So everything's now going to be in negatives, but not negative 330. This would be negative 30, negative 45, negative 60, negative 90. Does that make sense? And it has to do with how we're swinging and how we're thinking about the rotation of the angle on the unit circle. Another way to think of it is it's the reference angle, but we're rotating backwards, so it's negative. So again, they asked for negative 1/2, so let's go back. Here is when sine, the y coordinate is negative 1/2. That's right here, but it's not 11 pi over 6, and it's not 330. Since they asked for it in degrees, it would be this little chunk right here, which is just backwards 30. And if you have trouble with that, you can think, okay, well, all the way around is 360. So if I take that away to get the negative version, I'll give 330 minus 360, which will equal negative 30 degrees. Okay. if it was in radians, you'd have 11 pi over 6. Sorry, that's so like smushy. Minus 2 pi, which is 12 pi over 6. And you'd get negative pi over 6. Okay? That's a pi, not a 6. Okay. So what did we decide? We decided negative 30 degrees. Boom, negative 30, you don't need to type the degree symbol because it's right there. Okay, same process will happen no matter what your variation is. Let me just check to see if there's a cosine. Okay, so you'll find that where is it 0? Where is it 0? Oh, okay, there's where it's 0, right there. I gotta look at it now. Yeah, okay. Because sometimes that confuses us. 0, 0, the answer is 0. It's 0 degrees. Yes, it starts right there. So, alrighty. Well, I guess it's your lucky day. Since I did it for that one, I got to do it for the arc3. Root 3 over 2. Root 3 over 2 up here. Okay, so 60 degrees. Pretty straightforward. There it is. Cosine value. Root 3 over 2. Arc cosine gives you back the degree or the angle measure, and they are asking for it in degrees, so it should be 60, and you type 60. Cool. Question 1 and question 2, all variations done so quick. What is the value of arc cosine? So now we're looking at cosine root 3 over 2. So let's go to our book. We're going to go to the next page so you can see the cosine domain and range. So now cosine, the inverse cosine function, the arc cosine function, is going to spit out values from 0 to pi. So the degrees that it will, or the degree or the radian, the angle measure, will be positive 0 to positive 180 degrees and so forth up in here in this gray area. So let's go take a look. What are they asking? Root 3 over 2. So cosine refers to the y coordinate, root 3 over 2, pi over 6, right? We look for the first value in our ordered pair, pi over 6. I'm not going to do all of this so you guys can have some practice. Negative 1, there is the, okay, so look, there is where the x value, the x coordinate is negative 1. That's blurry, but that's pi. And then if you have question variation 3, I believe in you. You can do it, okay? Question 4, given, that sine theta equals x over 10, which expression represents theta in terms of x? Oh, yes. Okay. So what we're doing here is that concept of solving using an inverse to get what we're looking for by itself. So we have sine theta is equal to x over 10. They want us to solve for x. I'm like, what is theta in terms of x? Solve for x. So no, that's not what they're saying. So sorry. They want you to solve for theta. Which expression represents theta? So solve for theta. That's just still a placeholder. It's an unknown. We don't know what it is. So sorry. How do we do that? We're going to take the inverse of both sides. Because if we take the arc sine of sine theta, we're going to get just theta. And then if we take the arc sine of x over 10, we're going to get what theta equals in terms of x. Pretty cool. So now if we know what x is, we can solve for the angle. If we know what the angle is, we can solve for x. But right now they were just having you rearrange that equation. So this answer is looking for arc sine of x over 10 with parentheses. Arc sine, parentheses, x over 10, usually. Nice. There it is, arc sine, x over 10. Let's take a look at a different variation really quickly. All right, very similar. Arc cosine, x over 6. Okay. All right, cool. So that again is just a quick representation solving for the angle because that's what the inverse function does. The inverse for a trig function spits back out the angle where the original trig function is giving you the ratios of the sides of that right triangle that is formed. When you have the angles, you can always find a right triangle. It's pretty cool. Triangulation is very cool. All right, last question. A birdwatcher is 45 feet from the base of a tree and spots an oriole. An Oreo? No, at the top of the 140-foot tree. What is the angle of elevation from the bird watcher to the Oriole? Round to the nearest whole degree. Here we go. So questions 1 through 3, they had you practice using a unit circle to identify the angle given a sine or cosine value. Question 4 had you rearrange a function to solve for the angle measure. And now we're going to set up the word problem. We're going to solve for that angle of elevation. And we will have all of the skills that we really need to solve some pretty cool triangle functions out in the real world. Okay? Here we go. Angle of elevation from the bird watcher to the Oriole. So we need a tree. The tree is 140 feet. Okay. The bird watcher is 45 feet. This is not to scale. Not to scale. So to the top of the tree. So from the base of the tree to the top of the tree. They're just asking for this angle of elevation. And that makes sense, right? Because here's the ground. And we elevate it up. Or here's like the plane level. Like this is where it's 0 degrees. Wherever that is. And then we rotate it up. That's the angle of elevation. So 0 degrees. Kind of makes sense? Maybe, maybe not. Okay, this is the length. And we want to know this one, theta. We'll write theta. All right, well, do I know the hypotenuse? Is it given in my problem? No, it's not given in this problem. So I'm going to use the information they have given us, which is they gave me what we call the legs of a right triangle, the non-hypotenuse sides. If I don't have the hypotenuse, I think SOHCAHTOA, SOHCAHTOA. TOA, opposite over adjacent. And that's exactly what I'm going to use. So let's first just write it like this so you can kind of get used to this comfortable tangent. Theta is equal to the opposite over adjacent. Well, that's cool. We know what the opposite is. It's 140. We know what the adjacent is. It's 45. We want to know what the angle is, though. Not to worry, we can take the arc tangent, the inverse tangent of 140 over 45. They want it in degrees. Let's go to our nifty calculator, 140 over 45. Oh, it scared me. 140 over 45, I think. Okay, arc tangent, boom. 140 over 45. Oops, I need parentheses. See how that didn't work? 140 over 45, I'm pretty sure that's what it said. And we need it in degrees. Cool, we did it. It's already in degrees, not radians. It's in degrees. So they're saying, wow, it's actually pretty steep. 72.18, right? And I don't think it's the thousands. I think it was the hundredths place. So remember the rounding skills. Remember your decimal skills. Decimals are everywhere. Again, like I said, take a look at that gas station, the gas pump. Watch what it's doing. Look at those signs. They have decimals and fractions, lots of them. 72 degrees and 18 hundredths. Oh, to the nearest whole degree. Ha! We're just going to the ones place. 78? Yeah, 78. $72. It was 72. I just didn't remember the number. 72 and 18 hundredths. That's where the 8 came from in my memory, and I thought 78. But it's okay. There's the nearest whole degree. So you look again, if for the whole degree, you look at the ones place, then you look at the tenths place. If that was 5 or higher, even if that was a 5, we would round this to 73. But if it's a 43210, then it just stays a 2. Cool. Well, hopefully that was some fun. A quick quiz help video. Thank you for watching. That's what you're going to do for the rest of your variations if you didn't have this variation, or if you just want to try a retake to see if you can nail some of these examples of real world applications of the math you are learning. Good luck. This is the last quiz. Thank you so much. And I am very proud of you and excited for next semester. So